Okay, we've got our next small project here that we're going to go ahead and start on and try to get this thing finished up here. These are some parts that belong to a longtime viewer and follower of my channel, Bill Lawrence. He's out in Gilbert, Arizona, and he's on Instagram as at Banda Precision there. And so these parts are off of an Okuma and Hoa HL20 lathe, and he wants to do some modifications for these. I'm not familiar with all the sizing for the tool holders for CNC lathes, CNC machinery, but he told me this is actually built for the next size up. And what he wants to do is bore this tool holder. It's at 1 3/4 now. We want to bore it to 2 inches to fit this tool holder right there. So we need to bore that out so that have a slip fit for that 2-inch tool holder right there. The other thing that we need to do here is drop it by 20 millimeters. So this mounting surface right here, we need to bring this down a total of 20 millimeters. And I did some measuring here. I believe this was 100. It's 100 millimeter. If I get it squared up right, it's 100 millimeters. So we're going to bring this thickness right there down to 80 millimeters, and then this keyway is what lines it up in the machine there. So this is a 25 millimeter wide key. I'll need to measure to see what the height of it is there. He did say the key doesn't have to be in the center. We can actually make it all the way across. So the plan is to bring this down. We'll mill it down to 80 millimeters on height, and then we will mill so that it's got a 25 millimeter wide keyway across there in the center. It's got to be dead center. And let's just get a quick reference measurement on what this key is. So it looks like it's a 5 millimeter tall key there, so 25 by 5 keyway. All right, I believe what we'll do is we'll go to the Monarch lathe, use our 4-jaw chuck. This would be a good project for the channel where we can get this chucked into the 4-jaw, get it indicated, do our boring, and then after that we'll go to the K&T mill and use that to do our milling there. I did ask Bill, him having a having a CNC shop there, is this not something that he could do? He said this is certainly some stuff that he could do, but he keeps his machine set up for running multiple batch parts, and he doesn't want to tear it down just to do a one-off job like this. And this is not something that he's hurting for either. So he's been a long fan of the channel. He reached out to me a while back and said, hey, I got this little project. If you're interested in it, I'll send it to you, because he really didn't feel like messing with it because he stays busy on his production parts. So he sent it to me, and I've had it, and I'm going to try to go ahead and get it done for him now. So let's go ahead and get to it. First thing that I always do is get the chuck preset for our part. So I've over here and I've measured it out. We've got it so that it goes in there, and I wanted to point out something. So we've got an offset hole, so you can't evenly set the jaws equally. You want to offset it so that our hole is near the center when we start doing our indicating. And the thing that I usually do, let me grab my scale here. So one side is going to be even, it's 4 1/8. So we've got side to side, we've got them equally spaced, 4 1/8 clearance so that it slides in there. So what I do whenever I've got a part that's off center like that is I just take a rough measurement using my scale from the edge, and I eyeball it to the center of the hole, okay, just an approximate. It looks like 1 3/8 from the edge to the center. So take that and double it, that's 2 3/4. So what you do is you would set these two jaws to equally from the center to 2 3/4. All right, just like that. Once you have these set to that, you take your distance, which in this case is 100 millimeters, but I'm using my inch rule, so basically about 3 7/8 of an inch. So rotate it, leave one jaw alone, and now just open up this one jaw to 3 7/8, just like that. And then when we stick this in there, like so, the center of the hole is going to be near the center of the spindle there, so you don't have a bunch of offsetting that you have to do whenever you start indicating it. All right, so let's go ahead and kind of square it up some with the jaws, and then I'm going to put some copper pads in there. You want to use the soft jaws or the padding whenever you're indicating parts like this. I'm just kind of eyeballing it to see if it's square in the jaws or if it's going to be wobbling. Doesn't look too bad, and you can see the hole is not far off center there. So I'm going to go ahead and snug up the sides just to keep it from falling out. Go ahead and take one. We're just using, this is copper pipe that's just cut into pieces and then smashed in the vise. And what this will do is allow it to grip well, but also allow it to move whenever you go to indicate it, because you got to bump this thing around so that it's running concentric on center. And these types of jaws bite in pretty hard. These are the serrated jaws. So you want it to move. Whenever you're indicating, you want it to move. Alright, so we'll go to these other two here and go ahead and put our copper pads there. Just like that. Alright, so we'll go ahead and start our indicating. I've got to grab it and get it set up. We'll probably start with the face, and you want to get the face bumped around, and then we'll move to the bore, do that, and you have to keep going back and forth from the face to the bore until you get this thing running perfectly straight and true. We'll start first with the face here, and let's try to get it bumped around straight. I've got two indicators. We're going to have this one for our face, and then I got another one with the ID attachment that we'll use to go up in there. So I'll just move one noga out of the way and put the other one in. That is a lot straighter than I thought it was. Wow. Let's see if we can move it in so that we're missing those holes there. Alright, so that's the high right there. Let's see if we can tap it that way just a bit. That's the low, and that's the high. It's not far. A couple thousandths really. Low, high. Now it's going to move on me whenever I go to do the bore. So it's best just to get it within 1/2 thousandths. That's within one right there. So I am going to, let's move that one out of the way, and I've got this other one that we will bring in here. Got that ID attachment right there. That is the Starrett number 670 ID attachment. Make sure you can see this. All right. Need to come out a little bit further. It's not touching there. This is my favorite method of indicating an ID whenever I can. Keeps the indicator right here in front of you, and I always like to have my indicating right here in front of me like that, in that direction. I don't want to run an indicator on the top, because whenever I adjust the jaws, I'm usually looking at this position right there. Even though I might roll it to the front, I know that I'm using this jaw right there as the reference on the high and low. All right, so that's the high and that's the low. So this time we're going to tighten the lows and loosen the highs because we're on the inside. Push that low over. Go ahead and go to this jaw now. And this is why I said it's important to have some kind of soft padding in there so that you can get it to move. You don't want the jaws to bite into that metal, plus you don't want to mar it up anyway. Just keep working it. Before you know it, you're there. High, low. So even though we are showing it within 1/1000 here now, the face may be out again. So we'll move this noga out of the way, and we're going to bring this one back into the face. Then we moved it a few thousandths. What I'm going to do is go to the high, bump away from the indicator. So that's the high, so we want to tilt it that way slightly. Now that it's tighter, it's going to be a little bit harder to move, so you got to use a little bit more force on it. Low, high, within one. Getting closer now. Looks like we got a low spot in there. That's what it's measuring like. Let's just see if we can split the difference. Alright, that needle's jumping around a half a thousandths there. So now let's go ahead and jump back to our bore. Get it back on center line. Yep, we got a good 16 thousandths there. See if we can get you in there a little bit tighter to see that. I'm going to loosen the highs. And I'm going to tighten up the low here in front of me. Now we got to move to the other two jaws. Loosen that one, and we're going to tighten this low here. 1.5 thousandths. So let's just tighten the lows now. Half a thousandths. Still within a half a thousand. It's got a little bump in there somewhere, so that's going to be pretty good. I'm going to go back and check the face again, make sure we didn't kick it around. We got 1 thousandths we need to bump out of there. So that's within a half a thousandths. That's going to be good right there. So we'll do one more check of the bore. So yeah, we moved it about 3 thousandths. I'm just going to tighten it at this stage of the indicating. I'm not going to loosen it. I'm just going to try to push that side over. There's another low. We got it. We're going to call that running true, and we're going to set up our boring bar and do our boring now. So my tool I'm going to use today is my 1.25" boring bar. That's an Aloris brand boring bar, one of my favorite ones to get to use tool bits. It takes 3/8 square tool bits. So I am going to use one of my new Micro 100 brazed on tools for this. I'm going to have to go and cut it off because it's too long right now. So we know our hole is 1 3/4 in there. Let's go ahead and remove the protective peel coat there. Alright, so there's our brand new tool. So what I'll do is just I'm just going to kind of run it up in here about like that. I'm going to take my marker. That'll give us plenty of clearance. And I'm going to just put a mark here on the back side. I'll go over there to the vise and we'll use a cutoff wheel and not just cut that off, and then we'll come back and get it mounted in there. Hold it in the vise here, but not on the carbide. Just have the carbide sticking up above the jaw. Just like that. And we'll go over there to the belt sander and just deburr that back in. We'll be ready to go. Want to go ahead and measure this bar and make sure that we know what our size is that we're trying to hit. It looks like they've got it right, just about dead on, 2 inches exactly. So we are looks like between 2 and 3/10 under 2 inches. So we're gonna shoot for 2 inches maybe 2 inches of half dowel. We're just going to shoot as close as we can so that we got a precision fit there. Probably just go ahead and use a telescope gauge. I don't have a tri mic that size, but we can also use Granddad's 1 to 2 inside mic there to kind of verify our size there as well. I know this one's dead on. All right, we're ready to get started on this. Let's go ahead and let's get our touch off. Take 100 thousandths. So we've got a total of 250 to come out of here. We will have an interruption in there. There's one hole that goes through. You can hear it there. Go ahead and double check our sizing there. All right. Got another 150 to go. We'll use our telescope gauge to go ahead and get a check on the size here where we're at. Looks like we're right at 949, so we've got approximately 51 thousandths to bring it to size. What I'm probably going to do is go ahead and take a 20 thou cut, and then we'll finish it off. I'm going to use the inside mic here now to go ahead and check it. We should be about 12 thousandths off of our size. That's what it's looking like. About 12 thousandths. So what I'm going to do, I'm going to go ahead and split that into two also. I'm going to drop the feed rate down to 5 thousandths, make a 5 thousandths pass. We'll mic it again, and then I'll take whatever's left there at the end. So that's our 5 thousandths and 5 thousandths feed rate pass there. That should leave a nice smooth finish in there. And like I said, we'll measure it and we'll be able to take one more cut and hit it right on size. Alright, so we've made it to our finished pass after we get our measurement here. Just make sure there's no dust in the bore. Well, let me see what my telescope and gauge, my telescope gauge and my mic say. That's telling me 6 thousandths. 6 thousandths to go on the telescope gauge. And let's see what my inside mic tells me. Got to get it squared up, so it's kind of like using a traditional rod type of inside mic. You got to rock it and make sure that you're not crooked. So this one's saying 6 thousandths, really about 6.5 thousandths right there. So we can pull it out. Yep, 6.5 thousandths. All right, well, I'm gonna take 6.5 thousandths and see if that gets us on size there. All right, final cut. And I'm gonna back the tool out after that pass there so I don't drag the tool on the return stroke. All right, that's the end right there. So I'm gonna go ahead and just back the bar that way. Got a nice clean bore in there. Yeah, according to my mic, looks like we're, let me get it in there. Looks like I'm slightly under. Don't think we're going to be able to get it in there. Looks like we're at a metal to metal fit right where it's at right now, so probably going to have to go back in there. This needs to be able to slide in, so I should have taken a little bit more, probably another 0.5 thousandths on the dial. Yeah, I can tell that it's a metal to metal fit. So I'm going to have to try to get about a 0.5 thou out of that. I touched the bore off and just took like a half a line here. I've got this mag back set to an exact 0, so we'll use it kind of like when we do our threading. I don't want to drag the tool on the return, you know, bringing it back, so we'll back out and I'll be able to come back to the 0 if what I took there isn't enough. I'm just trying to create a very tight tolerance on this. I don't want it to be too loose. Probably 1 thousandths would be good on it, so I'm trying to get it under 1 thousandths. Looks like I got it at 1 thousandths over. Right at 1 thousandths over, so that should go in there. Make sure there's no dust in there. There we go. That's the fit we want there. Feels like there's chips still in there. It stopped. Oh yeah, that's a good fit right there. 1 thou clearance. Still got some chips in the back end. I need to get out of there, but it looks like we're ready to roll. We got it where we want it. We just got to chamfer it now. I'm going to give the bore a very light flap with this emery paper here. It's just wrapped around a 1/4 inch rod. Just try to remove any of the dust that's in there. It was getting right to the end and starting to get a little tight on me. All right, there we go. Got it. That is a nice fit right there. Perfect. All right, we still got to chamfer the corners, and then the lathe work will be finished up. So we swapped out our tool for this chamfering tool here. I'm going to go ahead and just crank it to the back, and we'll do that one first. I just look for that tool to come out past the shoulder. I'll bring it into it to where it just touches it. Back off, and we'll go ahead and spin the chuck up. All right. I'll back the tool out. come in and do the same thing here. Just like that. All right, our lathe work is now finished up. So time to go ahead and take this sucker out of here, and we'll go to the milling machine so we can get this thing milled down and get our key milled back in it. Usually to take out, I'd repeat the process, take the pads out just to keep them from falling down in the chip pan there. Just lightly chuck it, and then this one here will I'll just go ahead and loosen that one up. Well, loosen the side one back up too. Our pad and our pad, and there we go. And I'll come back here in a minute, and I like to blow this out with the air, get all the chips out of the chuck, and the rest of the lathe we'll wipe it down real good, make sure all this cast iron dust is off of it, and then I'll spray it all down with WD-40.